All right, this is Algebra 2, Lesson 49. I want you to smash, like, and subscribe. And turn notifications on. Hit that thumbs up right there. Okay, here we go. This is Algebra 2. Linear intercepts. Okay, linear intercepts. First of all, what does the term linear mean? Line, right? They're infinitely go to the negative x-axis and infinitely go to the positive x-axis. Okay, what are intercepts? So we have a line.
There are lines that intercept other lines.
Okay, intercepts. We have x-intercepts and we have y-intercepts, right? We have x-intercepts. What are x-intercepts?
They intercept the x-axis.
They intercept the x-axis. Are there other names for them?
Yes.
What are they?
That was a question.
What are they?
Lines.
I know.
X-intercepts. They're solutions. What are the other words?
Congruent. Variables.
Transversal.
Give us a hint. What does it start with?
R.
Reciprocals?
No. Roots. Roots.
Square.
And the next one starts with a Z.
Zigzags.
Wait.
Zebra.
What'd you just say?
Zebra.
No. No.
I have it in here somewhere.
Zero solutions.
Zero.
Zeros. Roots, solutions, zeros, x-intercepts. What dictates how many x-intercepts an equation has?
Number.
The square root. Or the
exponent.
The exponent.
All right. So it's the degree of the equation, which is the highest exponent. If I have an x squared, then I can have at most 2 x-intercepts. If I have an x cubed, then I can have at most 3 x-intercepts. If I have a line, how many x-intercepts do I have?
1.
1 and 1 only. When we have an x-intercept, what is the value of y?
0.
Okay, I want everybody to look. The value of y is 0 when it intercepts the x-axis. So if I gave you that as a coordinate pair, then we know that that is an x-intercept. Got it? All right, what about y-intercepts? Your book does not talk a lot about y-intercepts. But if the equation is a function, there's always only one y-intercept. So if we have a function, there's only and always one y-intercept, always. What is the value of x for our y-intercepts?
Undefined.
It's not undefined.
I was joking. It's 0.
Yes. The value of x is 0 when we have a y-intercept. So if I gave you an ordered pair like that, then you would know that that is the y-intercept. The y-intercept is always the constant value in an equation. It's always the constant value. So if I gave you an equation, a function, what is the y-intercept of this function? It's the constant.
Yeah, 3.
It's 3. Because when x is 0, that term's 0, that term's 0, y is 3. It's always your constant, and there's always only one. All right, so for this lesson, normally we go from an equation to graphing. Now we're going from the graph, and you do not see the y-intercept, and you have to go to the equation.
What? Sorry, this is kind of a question.
No.
Not directly related, but what lessons are we testing?
37 to 48. We're going to go over those in just a minute. 37 to 48. All right. So let's look at, we're going to look at this line right here. So bottom right. All right, when you look at this line, we have an x-intercept. But what's the formula for a line? Y equals mx plus b. In order to arrive at the equation, we need the slope and the y-intercept. But we don't know what the y-intercept is. It's outside of this image.
But if we know what the slope is, we can find the y-intercept.
But what do we know about the slope? Is it positive or negative?
It is negative.
Okay, it's negative. And what do we know about the y-intercept?
It's positive.
It's going to be a big positive number, probably. All right, and it better be a lot greater than 6. Right? All right, so make sure you're engaging your logic as you arrive at these. Can we come up with the slope?
Yes.
Yes, we have 2 points. Or you can just look actually at the line. Can somebody already tell me the slope?
Negative 6.
It falls 6
And
as
run
it
1.
runs 1. Do you see that? Okay, let's say you couldn't have seen that it falls 6 as it runs 1. Then you have 2 points. You have 3, 6, and you have 4, 0. Can I calculate the slope?
Yep.
What is the slope? The change in
Y.
y over the change in x. So it's 6 minus 0 over 3 minus 4, which is negative 6.
Why'd you get the 3?
This point here was an obvious point on the graph. So that's 3, 6, and that's 4, 0. So it's a change in y, 6 minus 0, of the change in x, 3 minus 4. Okay? So we have the slope. Now, I have a slope and I have 2 points. How am I going to arrive at the equation?
Slope y-intercept. Slope intercept.
No, there's another form.
Oh yeah, point slope.
Point slope. Somebody tell me what the point slope is.
Y minus y sub 1 times.
Equals?
Oh yeah, equals x or m.
Slope?
Yeah, slope times x minus x sub 1.
Yeah. All right, you're going to use the point slope. I'm going to use 4, 0 because it has a 0 in it. I don't have to worry about the 0, right? So that's y minus 0 is the slope, negative 6, times x minus 4. So the left-hand side is just y. I distribute the negative 6, and I have negative 6x plus 24. That makes sense to me. I do believe that probably crosses the y-axis at positive 24.
Hey, so we already knew how to do this. I just like.
You just don't see. The only difference is you don't see the y-intercept now. All right. I do want to talk about transversals. All right, that's a second.
Just like using everything we.
Correct. You just don't see the y-intercept. That's what's changed in this lesson. You don't see the y-intercept.
So you basically find the slope,
Find the slope.
put it in point slope form, and then solve.
Correct.
That's it.
All right, I do want to look at the second part of this lesson
Oh, God.
on transversals. All right, so this goes back to geometry. We have parallel lines.
I suck at geometry.
Okay.
All right, and then we have a right triangle. And we're given this. That is z degrees. This is A, B, 7, and this really is P degrees. All right? All right, so how is Z related to 153? Remind me.
It's
Linear pair.
They're a linear pair, and the sum of linear pairs is?
180.
They're supplementary 180. So what's the value of Z?
To 27.
27 degrees. All right? Now, I'm never going to use 27 to solve for P. I'm going to go back to the 153. So how is the 153 and P related?
They're also.
They're supplementary because Z and P
Aren't
are
they-
corresponding.
Aren't they equal?
So they're equal.
Yeah.
Yeah. So P is also 27 degrees because 180 minus 53 is 27. All right, for your test, guys, you have got to know the trig. You've got to know it
So good to know.
well. And you have to know
This next test that we have. is on-
cosecant, secant, and cotangent. You have to know those three. Yes, I'll go back over those. All right. Now, I want everybody to look at the triangle. It's a right triangle. So we're using trig. I want everybody just to think, what trig ratio am I going to use to solve for A? Don't say it, think it. What trig ratio am I going to use to solve for A? Does everybody have it in their minds? Yes, your next test is heavy trig because this is foundational for pre-calculus. All right, so I just want to know, in relation to angle 27, A is what side?
Adjacent.
Adjacent. 7 is the hypotenuse. So I'm using the trig ratio that uses adjacent and hypotenuse, which is cosine. So tell me what I write, Sam.
Aren't you not supposed to use things you
I
found
have to
out?
use 27.
Okay.
I have to use something inside. So I better get it right.
It's
So what am I going to write?
7 divided by cosine 27.
Okay, just give me the original equation.
Cosine 27.
Cosine of an angle equals
A over 7.
A over 7. When the number's in the denominator, that's when I'm multiplying. So I'm multiplying both sides by 7. So you'll do that in your calculator. 7 times the cosine of 27. It better be less than 7 because the hypotenuse has to be the longest side.
6.23.
6.23. Someone else confirm.
Yeah. Yep.
So you better have your calculators on Thursdays. Okay? All right. Now everybody think about B. Let's solve for B. What side is B in relation to the 27 degree angle?
Opposite.
Opposite. And we still have, God bless you, the hypotenuse. Now I'm not going to use A because A is a rounded number. All right, I'm definitely going to use B, and I'm going to use 7. So what trig ratio uses opposite and hypotenuse?
Sine.
The sine. So what do I write, Allie?
Sine of 27 equals B over 7.
Correct. I'm going to multiply both sides by 7. What's 7 times the sine of B? Sine of B. Sine of 27. 7 times the sine of 27.
3.178.
Okay. Then I'm going to ask you one more question. Does it make sense that side B is shorter than side A?
Yes,
Why?
because both the hypotenuse and the adjacent are very long, which would make the leg B shorter.
Okay. Why, Evangeline?
P is small, so the A would be small too.
This angle is 27 degrees. What is that angle? If this one's 27, what's that angle?
53? No.
The sum of those, yes,
53?
they're complementary. They have to be 90 degrees. This is a bigger angle. Sides, remember, the length of a side is dictated by the angle. If I have a very small angle,
The 63.
the side is going to be very short opposite it. If I have a really big angle, then the side opposite it is going to be longer. So knowing that this is 53 degrees, that side better be longer than that side.
I think it's 63. I messed up.
Yeah, 63. Thank you. All right. All right. Now, just for a little
You're
review,
welcome.
Thank you. Sorry.
let's take.
Thank you.
Welcome.
All right.
I'm sorry.
Everybody look. We're just going to look at angle A. Quick review. And then you'll work the practice problems. Okay, we're just going to look at A. Ready? Caleb, what's the cosine of angle A?
Of angle A.
Yeah. Cosine is what?
That's opposite over hypotenuse.
No, cosine is what? Cosine of any angle. I better write the angle. Equals. It's, what's my saying?
So it's
Oh, adjacent over hypotenuse.
All right, write that on your test. Okay, I'll rewrite it.
Do you have, it looks sine and then opposite of hypotenuse and then cosine adjacent over hypotenuse.
SOHCAHTOA.
Sine is
Because Miss Haley likes a pedicure.
Thank you. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent.
Do you have one for the
Where did
skid?
Haley like
I'm going to tell you in just a minute. All right. I don't have a SOHCAHTOA like
toe.
so nice like that, but I do have hints.
toe.
Okay. So the cosine. Now say it. What's the cosine?
Adjacent over hypotenuse.
Which is what?
Which is 8 over, no,
6
it's 6 over 10.
6 over 10.
Wait, oh yeah.
All right, Allie. What is the I was going to say so kind. Sine. Sine.
8 over 10.
8 over 10. Yes. Kamaya. Tangent.
8 over 6.
8 over 6. Only the tangent can be greater than 1 or less than negative 1. All right. Then we have the cosecant, the secant, and the cotangent. This is CSC, this is SEC, and
The
this is
SEC.
COT. I know, SEC.
They should
All right.
switch the names on that. It makes it so much
100% they should, but I was not around when they came up with these names. Okay, so I just want you to note, say the words, and it's the third letter. This is the inverse of the sine. So The cosecant is the inverse of the sine. It's hypotenuse over opposite. Got it? So say yes. Yes. Third letter tells you what is the inverse of. What it's the inverse of. All right, so, and it's hypotenuse over opposite. It's 10 over 8.
Okay, and then the next one would just be hypotenuse over adjacent.
Hypotenuse over adjacent. 10 over 6.
And then adjacent over opposite.
Adjacent over opposite, which is 6 over 8. Got it? So this is ho ho ho. Did you know? And this is, I might be laughing at you.
Ha ha ha.
Yeah. And this is, yeah.
Oh ha ha.
Yeah.
Ha ha.
Think Hawaiian. I don't know. That makes me think of Hawaiian.
Magister Benjamin.
Ao's Hawaiian.
No. Ayo. And there we go.
Wait.